everyone, in this video we will be solving exponential equations. This is the second part. I will put the link of the first part in the description box below. In an exponential equation of the form b to the power x is equal to b to the power y, the x and y are equal to each other if both bases are the same. So again, this exponent x and exponent y would be equal each other if and only if their bases are the same. So if both are b here. So let's take this first example. Now, looking at the rule that we have established at the beginning here, they have to have the same base. But in this case here, our base is 5 and our base is 1 over 25. So then our task is to make sure that their bases are the same so that we can have their exponents equal to each other. So in this problem that we have here, if we look at 125, we can change this to a base of 5. So I'm just going to write the 5 here. So that's going to be 5 to the power 2x. And then I can change this 125 to an exponential form with a base of 5, because if I raise 5 to the power 3, that means 5 times 5 times 5 would be 125. So I can go ahead and rewrite this as 1 over 5 to the power 3. And then, because again, 5 to the third is 125. That means 5 times 5 times 5 is 125. And then this is to the power x minus 5. Now, looking at this two bases here, they are not the same because we wanted to have the same base. This is just 5 and this is 1 over 5 to the third. Now, using the properties of exponents, once we flip this fraction, we are going to switch the sign of their exponents. So then we can go ahead and rewrite this as 5 to the power 2x. That would be equal to, again, we flip this fraction. I can rewrite this as 5 to the power negative 3 over 1, but then I don't have to write the 1 because the 1 becomes invisible. So these two right here, or these three right here, are equivalent expressions. So 1 over 25, 1 over 5 to the power 3, or 5 to the negative 3. These three are just the same. And so this one right here is to the power x minus 5. Now we are going to, now as you can see here, we can already distribute this exponent right here to each of the terms inside the parentheses. Again, be sure you don't miss this because others miss this part. They only distributed it to the first one. It has to be to both of them. So looking at this, we can come up with an equation as 5 to the power 2x is equal to, that's gonna be 5 to the power negative 3 times x is negative 3x, and then negative 3 times negative 5 is a positive 15. So then, as you can see here, we already have the same base. Both bases are 5. Now, since we already have the same base, we can therefore solve for the x by putting their exponents equal to each other, since both bases are the same. So this 2x and this negative 3x plus 15 would be equal to each other. So I'm going to show the work on the side over here to solve for x. So that would be 2x is equal to negative 3x plus 15. So then from here, I can go ahead and add 3x from both sides. So that's plus 3x plus 3x. And so this would equal to 5x is equal to 15. So then from here, I'm going to divide both sides by 5, divide this by 5. So then the x is 3. So our x value is 3 for this. Now, we can check our work if we got it right or not. So I'm going to show the checking process right here. So we will check our work if we got it right. We can actually use this equation that we have over here, since all these three are equivalent. So we can go ahead and just use this to see if both sides are equal. So I'm gonna use this equation that I have here. So that would be 5 to the power 2x. So that's 5 to the power 2. And then again, our x was 3. So I'm just gonna go ahead and put 3 right here. So that's 5 to the third. And we're not sure of it yet. Is that equal to 5 to the power? That's gonna be this one right here. So that is negative 3. Then we put in the 3 that we got plus 15. So again, this is gonna be 3 right here. So since that's the x that we solved, that matches up here. So our answer here would be 5 to the power 15, because no, 5 to the power 6. 5 2 times 3 is 6. Is that equal to 5 to the power? That's negative 3 times 3 is negative 9 plus 15. So negative 9 plus 15 would be 5 to the 6 is actually equal to 5 to the power of 6. So we got both sides equal to each other. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, and pause it and check your answer. Okay, so we go over the problem here. So again, our task is to make sure that their bases are the same before we can equal their exponents to each other. So then from here, we have 16 and 8. So both of these can have a base of 2. So I can go ahead and rewrite this as 1 over. That's gonna be 2 to the power. So how many times do I multiply 2 so that it becomes 16? So that would be to the power 4. That means 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So that is 1 to the power 16. They're equivalent. And this is raised to the power 2x minus 10. And then on the right side here, I can change this to an exponent of 2. That is actually 2 to the power. How many times do I multiply 2 to make it to 8? And that would be 3 times. That means 2 times 2 is 4 times 2 is 8. And that is still raised to the power 4x. So then from here, we can simplify this since we cannot... they don't have the same basis here, because that is 1 to the power 1 to the 1 over 2 to the power 4, and this is 2 to the power 3. So we need to make them even. To do that, we are going to flip the fraction, and if we flip the fraction, we switch the sign. So this would come out 2 to the power negative 4, and then that is to the power 2x minus 10. And that is equal to 2 to the power. We can already distribute the 3 to both terms, to the term inside the parentheses, which is 4x. So I can go ahead and write this as 12x right here. So then from here, we can distribute this 4 to each of the terms inside the parentheses. Again, be sure that it's both terms, because others just distribute it to the first term, not to both of them. So it has to be both of them. So in this problem that we have here, this would come out 2 to the power negative 4 times 2x is negative 8x plus 40. Because we have a negative 4 times negative 10 is a positive 40. And that is equal to 2 to the power 12x. As you can see here, we already have the same base of 2. So then, since both bases are the same, we can go ahead and equal these two expressions to each other. So this negative 8x plus 40 would be equal to 12x. And then from here, we can go ahead and solve for x. So then we can go ahead and write this expression right here. So negative 8x plus 40 equals 12x. And then we want x by itself. So we're gonna subtract 12x from both sides. Subtract 12x from both sides. So this would come out 0. So 12x minus 12x is 0. This is negative 20x plus 40. And so we're gonna subtract 40 from both sides. So minus 40 and minus 40. So then we are left with negative 20x is equal to negative 40. So we divide both sides by negative 20 divided by negative 20. So then the x is positive 2. we can check our work by plugging in this 2 back into this equation right here. So I'm going to show the work on the side here. So let's check if both sides of the equation would be equal. Again, all of these are equivalent. Now, others are going to say, can I use this to check? Yes, you can do that. But since they are all equivalent, we can therefore use this to check our answer. So then we can go ahead and write 2 to the power. That's going to be -8. Then we put in the 2 there plus 40. Is that equal to? That's going to be 2 to the power. That's 12, and then we put in the x that we got. So the x that we got here is 2, so I put in 2, I put in 2 here. So this would come out 2 to the power. This is gonna be 2 to the power. That's -16 plus 40. And then that is, we're not sure if that is equal to 2 to the power 24. So that is -16 plus 40 is 24. And that is equal to 2 to the power 24. So both sides of the equation, both these two sides right here are equal to each other. Did you get the same answer as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya.